This is video 4 for the invisible light unit. Let's talk about some different types of medical imaging technologies. The first and the most popular and most known is going to be X-ray. X-rays really, these are just shadows. You see, the X-rays can pass through soft tissues and water molecules very easily, but they are absorbed by bones or really heavy elements like calcium. So when you have an X-ray taken, X-rays pass through you, except for your bones. And some of the heavier tissues can kind of absorb some of them, so you can kind of notice, like in these pictures of the two hands, you can kind of get like an outline of some of the skin and other connective tissues. So again, these are shadows, and it's caused by heavy elements. So they're being absorbed by some of the heavier elements. Again, another use for X-rays would be in industry and national security. High frequency X-rays and gamma rays are sent through cars and trucks and containers to look for heavy materials like uranium and plutonium. The next type is called an MRI. This is a magnetic resonance image. Medical magnetic resonance imaging maps the distribution of hydrogen. The density of hydrogen is greatest in soft tissues like the brain and tongue. So notice that you cannot see teeth in the images above. You know, this image right here is an MRI image. You can't really see teeth in that because there's not a lot of hydrogen in your teeth, but there's a lot of hydrogen in some soft tissues. So what this does is it detects the wobble of hydrogen. So the patient is placed in a strong magnetic field. And we can get that, if you remember, from a coil of wire. So we just have a really, really large coil of wire. And using electrical currents, we can make a magnetic field inside that coil. So it's one way of going about that. Protons act like tiny magnets. So they respond to the external magnetic field, and that causes the protons to line up. Now I say protons because remember that a hydrogen atom is really just a little tiny proton with an electron around it. So by talking about protons, I'm still talking about hydrogen here. So the protons act like magnets and respond to the external magnet, that big coil of wire, and it causes them to line up. A radio transmitter is then used to create a rotating magnetic field, and that causes the protons to wobble. This wobble can then be detected with a second radio receiver. So let's see if I can put that down here. So So that, in a very, very roundabout way, is how an MRI works. Now, I'm sure it's a little more complicated than that, but for the scope of this course, we don't have to get too much more complicated than that. The next type is called a CAT scan. Um, and really, this works in the same way that an X-ray works. So here's the difference. We take several X-rays from different angles. And then we use a computer to make a 3D image from all of those. Now, taking it from several different angles, we call that tomography. And then using the computer we call that computer aided. So what CAT stands for is computer aided tomography. So that's what the CAT stands for in CAT scans. The last type I want to talk about is a PET scan. This relies on positrons. And this is a simple form of antimatter. Certain isotopes emit positrons, so instead of alpha and beta particles. These isotopes are extremely useful in medicine. So here's a list of positron emitters and their half-lives. So first we have carbon-11 has a half-life of 20 minutes. And then oxygen 15, fluorine 18, and iodine 24. So to use a PET scan, you prepare a material that contains a positron emitter, so one of those 5 isotopes. So for example, we might use iodine 124. The iodine tends to concentrate itself in the thyroid gland of a patient. So if part of the gland is not functioning right, that part might not get its share of iodine. So when the iodine 124 emits a positron, the positron doesn't travel very far before it hits an electron and annihilates, producing 2 gamma rays traveling in opposite directions. These gamma rays then leave the thyroid and are detected with gamma ray detectors. So the instrument does not know where the gamma rays come from, but it knows that the origin was somewhere along the line connecting those 2 gamma rays. So we make this image by taking millions of gamma rays, analyzing them, kind of like the CAT scan does, and it gives us a picture of the thyroid. So again, another example of tomography. So any part of the thyroid not functioning properly will have blank spots from a lack of the iodine 124. Oxygen 15 then would be used to scan the brain in kind of the same fashion, but the short half-lives of these materials mean that the medicine will not stay in the patient's body for very long. So the scans must be done quickly, and since they don't stay very long, we don't really have to worry so much about the patient getting cancer from the medicine. All right, that concludes our unit on invisible light.